Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss various operators in Python in detail. So I request everyone to watch the complete video for better understanding. Python supports various operators such as arithmetic operators, comparison operators, logical operators, bitwise operators, assignment operators, and identity operators, and also membership operators. These are the 7 operators the Python supports. Now first let me discuss what is meant by an operator. Operators in general are used to perform operations on values and variables. Suppose let's take that you have an expression called a plus b. Now here a and b are called as operands, and this plus is called as an operator. Now a and b are the operands. Now what will happen in any programming language, if you give an expression called a plus b, whatever the value stored in the variable a and whatever the value is stored in the variable b, those two values, the addition will be performed and the result will come. Is it clear? Suppose let's take that in the variable a value 5 is stored, in the variable b value 6 is stored, and if you are writing an expression called c is equal to a plus b, and then you are writing another statement called print c, then a plus b is an expression. Okay, now a, what is the value? 5 plus, what is the b value? 6. So 5 plus 6, 11. That value will be assigned to the variable called c, and then you are printing that variable. So 11 will be printed as an output. So where a and b are the operands and plus is an operator. And one more thing also we can do. Suppose let's take the d is equal to 7. You can write an expression called e is equal to 7, not 7, d plus 1. Now here what is the d? D is a variable and 1 is the value. So we can perform the operation between the two variables or between the values also. Is it clear? You can write 1 plus 2 also. Is it clear? So this is about an operator. Now let me discuss in detail about the arithmetic operators. We have various arithmetic operators such as addition, okay, subtraction, multiplication, division, modulus division, then you have the floor division, and then you have the power. These are the various arithmetic operators the Python will support. Now let me discuss about the addition. Suppose let's take that a is equal to some 5, b is equal to 2. If you are writing a plus b, so 5 plus 2, 7 will be displayed. Is it clear? In the print, if you are writing a plus b, value 7 will be printed. So that is about the addition. If you are performing the subtraction, if you write a statement called a minus b, and if you are printing that one, 5 minus 2, 3 will be displayed as an output. Then if you want to know about the multiplication, you can simply write a into b, which is equal to 5 into 2, 10 will be displayed. Is it clear? Then division. Okay, now let me discuss about the division in detail for you. Okay, now a by b, okay, which is about the value which is there in the a division b. What is the value which is there in the variable a? 5. What is the value which is there in the variable b, which is 2? So it will give the output as, if you are printing it, it will be given an output as 2.5. Is it clear? So this is about the division. Now if you want to find the only remainder, that is what the modulus division. Is it clear? So a modulus b, then 5 modulus 2. Always the modulus operator will give you the remainder. If you do the 5 modulus 2, you will get the remainder as 1. Okay, so we have discussed about the addition, subtraction, multiplication, division and modulus division. Now let me discuss about the floor division. A floor division b, if you are writing, then 5 floor division 2, which is equal to 2. Why it is that normally if you do 5 by 2 you will get 2.5. If you perform the floor operation you will get the value 2. Is it clear? So it will give you the integer. Okay, are you able to understand? Now let me discuss about the power. So power you will represent like this. Now a power b, which is nothing but a power b only. So if you give the a value as 5, b value is 2, it will give you the value as 25 because it is 5 power 2, which is 25. Now let me show the practical things about the arithmetic operators in the Jupyter notebook. Now I will take two variables a and I will assign the value 5, and another variable I will take b and I will assign the value 2, and then I will start performing the arithmetic operations. First I will perform the addition. So a plus b, if I do, that value will be stored in the variable called c. Similarly, d is equal to a minus b. Then I will write e is equal to a into b. All the arithmetic operations I will perform. Then f is equal to a division b. Then g is equal to a modulus b. Then h is equal to a floor division b. Then I is equal to a b. Now you can check it. What is the c value will be? Now we need to use the single line comments. So for using the single line comments we can use the hash symbol. So c is equal to a plus b. What is the a value? 5 and b value is 2. So c will get the value 7. Similarly d will get the value as 5 minus 2, which is 3. Then if you look at the e is equal to a into b, which is 5 into 2, which will be 10. Then if you look at f is equal to a division b, so which will be 5 by 2, you will get the output as 2.5. Then we are using g is equal to a modulus 2. 5 modulus 2, it will give you the remainder, which is 1. Now h is equal to a floor division b. So floor division will give you the integer, which will be 2. Then we are using the power operator. So a power b, which is 5 power 2, which is 25. Now we will verify whether we are getting the output or not. So I will write print c, then print d, then print e. Let me copy them and then paste it so that we can save the time. Okay, f g h. Okay, then let me write print I. Now we will see the output, what will happen. See, we got 7, 3, 10, 2.5, 1, 2, 25. So this is the way the arithmetic operators will work. Now let me discuss about the comparison operator. The comparison operator or the relational operators are used to compare the things. Now let me look at here. Comparison or relational operators are used to compare the values. It either returns true or false based on the condition. We have several comparison or relational operators are there, such as less than or equal to, greater than or equal to. We have equal to, and we have not equal to. These are the various relational or comparison operators the Python will support. Now let me discuss with a simple example all these operators. Let's take that a value is some 10, b value is 9. Okay. Now first let me discuss about the less than operator. If I write print A less than B. Now look at here, A less than B. What is A value? 10. What is the B value? 9. Whether 10 is less than 9? No, false. So it will print the statement as false because this condition is wrong. If the condition is wrong, then it will print the value as false or it will return the value as false. If the condition is true, it will return the value as true. Okay. Now, if I write less than or equal to, now check it. 10 is less than or equal to 9. 10 is not less than 9. 10 is not equal to 9. So the condition is false. If the condition is false, then it will print the value as false here. So this is about less than and less than or equal to. Similarly, greater than. Now check it. A is greater than B. Now 10 is greater than 9. Yes or no? Yes, 10 is greater than 9. So then it will print the value as true. Okay. Now let's take that. If I use A greater than or equal to B. Now check it. 10 is greater than or equal to 9. First we'll check 10 is greater than 9. Yes. 10 is equal to 9. Wrong. But 10 is greater than 9. So this condition is true. So it will print the value as true for you. Is it clear? So this is about less than or equal to, greater than or equal to. Now let me use the comparison operator which is equal. Now lot of people will confuse with these two things. Suppose let's take that A value is some 10. If you write B is equal to A, then whatever the value which is there in the variable A, that value will be stored in the variable B. But if you use B is equal to A, then meaning is that whatever the value which is stored in the variable B will be compared with the value which is there in the variable A. Now look at here. What is the value which is stored in the variable B is 9. Whatever the value which is stored in the variable A is 10. Now check it whether 10 is equal to 9. Wrong. So then it will return the value as false for you. Okay. Similarly, we have not equal to. If I say B not equal to A or A not equal to B, check it. Whether 9 not equal to 10? Yes, condition is true. Because 9 is not equal to 10. So this condition is true. In that case, it will return the value true. I hope it is clear for you all the comparison operators. Now let me show the practical things in the Jupyter notebook for better understanding. Now we will take two variables A. For A, I will assign the value 10 and for B, I will assign the value 9. Now we will see the comparison operators. First, I will use less than. I want to verify whether A is less than B or not. Okay. Similarly, I want to compare A and B whether A is greater than B or not. Okay. Then I want to verify whether A is less than or equal to B or not. Then I want to compare whether A is greater than or equal to B or not. Then I want to compare A is equal to B or not. For equal, we will write double equal. Okay. Then if I want to verify A not equal to B or not. Now, as the comparison operators always will verify whether this condition is true or not. Now look at this one. A less than B. 10 is less than B. It's wrong. So you will get the output as false. Okay. Similarly, look at the next one. A is greater than B. 10 is greater than 9. Yes, the condition is true. So you will get the output as true. Now if you verify A less than or equal to B, A is not less than B and A is not equal to B, so it will return the output as false. Similarly, if you look at A greater than or equal to B, A is greater than B, so it will return the true. Now if you look at the next one, A equal to B or not, we are checking. Now double equal to is for comparison, whereas single equal to is for assignment. So now we are comparing the value which is there in the variable A and the value which is there in the variable B, are they equal or not. 10 is not equal to 9, so it will return the false. Similarly here, if you look at not equal, 10 is not equal to 9, it is true. So this is the output we should get. Now let me verify whether we are getting the same output or not. Look at here. We are getting false, true, false, true, false, true. So this is the predicted output and the same output we got. Now let me discuss about the logical operators. Python supports three logical operators such as logical AND, logical OR, logical NOT. These logical operators are used to combine conditional statements. Now let me discuss the working process of logical AND, logical OR, logical NOT. Now, as I said, logical operators perform logical AND or NOT operations. It is used to combine conditional statements. Now, let me discuss with a simple example. Let's take that A is equal to true. Now, what is the data type of this variable A? We no need to specify the data type, but if you write statement type A, then it will give you the output as boolean. So, if you want to try it also, you can try type A. If you want to know the data type of the variable A, because it is a boolean value, so you will get the output as bool. Okay, is it clear? Now this is not our focus. Now if I write B is equal to false, and if I say print A logical AND B. Remember one thing, in C programming language we will represent the logical AND operation like this, but whereas in Python we will simply use AND only. Similarly, in C programming language logical OR will be represented like this, but in Python we can simply represent like this, print, okay, A or B. Is it clear? Similarly, NOT operation, logical NOT, we will represent like this. But in the C programming in the Python, we will represent it as print not A. Now let's see what will be the output. Now A is consists of a boolean value called true, B is consists of boolean value false. Now true, logical and false. Now what is true, logical and false? If both the conditions are true, then only the logical AND will give you the output as true. If any one of the condition is false, then it will return the false. If you consider this is the condition 1, this is the condition 2, if you are performing the logical AND, true and false, it will print the output as false for you. Similarly, if you write condition 1 logical or condition true, now if you look at A is having true, logical or false. Now remember the working process of logical OR. If any one of the condition is true, then it will return the true. If both the conditions are false, then it will return the false. Now if you look at true, logical OR B. Now as this is true, okay, now it does not depend whether B is true or false. If B is true, see look at here, A is true, logical OR B is there. Whether B is true also, the entire condition will be true. Even if the B is false also, the entire condition will be false. So whenever the first condition is true, it will not evaluate the second condition and it will display the output as true for you. Now look at this one, not A. What is the not operator? It will give you the reverse. If it is true, not will give you the false. If it is false, not will give you the true. So not true, which will be false. So I hope you have understood the working process of logical operators. Now let me discuss these things practically in the Jupyter notebook. Now I will take a variable A and I will assign the boolean value true. Similarly, I will take another variable B and I will assign the boolean value false to it. Now I want to verify whether the logical AND will it give true or false. So I will use print A logical AND B. Similarly, I want to verify logical OR. So print A logical OR B. Similarly, I want to verify logical NOT. So I will use NOT A. Now we will guess the output. Now if you look at A is true and B is false. So we are using logical AND. If both the conditions are true, then only the entire condition will be true in the logical AND. But if you look at A is true and B is false, so logical AND will give you the output as false. Now, coming to the logical OR, if any one of the condition is true, then it will give you the output as true. So here A is true, so it will stop evaluating the condition 2 and it will give the output as true. Now look at the next one, not A. So A is true, so not A is false. So this is what I am guessing. Now let me verify whether it is correct or wrong. See, we got false, true, false. So our guess is correct. This is the way the logical operators will work. Now let me discuss about bitwise operators. Bitwise operators are used to perform bitwise operations on integers. The given integer will be converted into a binary number. On the binary number, each bit by bit, the corresponding bitwise operation will be performed. We have various bitwise operators such as bitwise AND, bitwise OR, bitwise NOT, exclusive OR, left shift and right shift. Now let me discuss each operator in detail for you. As I said earlier, we have bitwise AND, which will be represented like this. We have bitwise OR will be represented like this. We have bitwise NOT will be represented like this. We have bitwise exclusive OR will be represented like this. Then we have right shift, okay, and then we have left shift. These are the various bitwise operators. Now let me discuss each one in detail for you. First let me discuss about bitwise AND. Okay. Now if I write a small code in the Python saying that A value is equal to 4, B value is equal to 7, if I write print A bitwise AND B, then we need to verify what will be the output. Now, if you represent 4 in a 8-bit representation of the binary number, then we will represent like this. 4 will be represented as 1 0 0 0 0 0 0 0. This is the MSB to represent that whether it is a positive number or negative number. As it is a 4 is a positive number, we will represent it as 0. If there is a negative number, you will have the value 1 here. Okay. Then you have the 7. 7 we will represent it as 3 ones. Okay. 0 0 0 0 0. Okay. If you have any doubts related to the conversion of decimal number to binary number, I request you to watch my videos on the number system in the digital logic design course. Okay. Now I need to perform bitwise AND. What is the bitwise AND? How it will work is that if both the bits are 1, then only the output will be 1. If any one of the input is 0 or both the inputs are 0, then the output will be 0. Now if you look at 0 and 1 will be 0, 0 and 1 will be 0, and 0, 1 and 1 will be 1, and the rest of the things will be 0. So, if you perform bitwise AND operation between the 4 and 7, we got this number. Now, if you look at this is, if you convert into decimal number, you will get the value 4. So, if you print it, you will get the value as 4 here. Okay, so this is the way the bitwise AND operator will be worked. So as I said, it will be worked on the integers. The given integer will be converted into a binary number. On the binary number, on each bit by bit, the corresponding bitwise operation will be performed. Now let me discuss about bitwise OR. Okay, I will make everything same. Okay. Instead of bitwise AND, I will use bitwise OR. Okay. The bitwise OR will be represented like this. So I have the A value 4 and B value 7. Now I want to perform the bitwise OR. Now if bitwise OR is performed on the bits, If any one of the input is 1, suppose let's take that you have 0 and 1, the output will be 1 because any one of the input is 1. Even if both the inputs are 1 also, the result will be 1. So 0 1 it will be 1, 1 0 it will be 1, 1 1 the output will be 1. If it is 0 0 it will be output will be 0. So this is the truth table of the OR. Okay. So now if you look at 0 and 1 is there 1, 0 and 1 is there 1, okay, 1 1 is there. So if you perform bitwise OR you will get 1, then rest of them things are will be 0. So if you convert this binary number to the decimal number, you will get the value as 7. Okay, so this will be 7. Are you able to understand how we are converting? If I have 3 ones, how I am converting into decimal number is the weight of this one will be 2 power 0, the weight of this one will be 2 power 1, the weight of this position will be 2 power 2. So which is 1 into 2 power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2, which is equal to 1 plus 2 plus 4, which is equal to 7. Is it clear? So this is about bitwise OR. Now let me discuss about bitwise exclusive OR. Oh, I should have not erased. Anyway, I will discuss about bitwise exclusive OR. Then we will discuss about the unary operators such as left shift, right shift, and then not. Okay, bitwise exclusive OR. Now you have bitwise exclusive OR, we will represent like this. Now if I represent 4 in the 8-bit binary number, it will be 4 zeros, another 0, 1, 0, 0. Similarly, if I convert the 7 to the binary number, I will have 5 zeros, 111. Now, what is the exclusive OR? The exclusive OR, if you have x exclusive OR y, you can represent it as x into y complement plus x complement and y. So, if x and y are 1 and 1, then it will be 1, 1's complement will be 0 plus, again x value is 1, so it will be 0, y value will be 1. So 1 and 0 will be 0, 0 and 1 will be 0, 0 or 0 will be 0. So what I want to say is that if both the inputs are same, the output will be 0. If you want to verify, you can verify it. In place of x as 1 and y as 1, you can keep x and y as 0 and you will get 0 only. If any one of the input is different, or I can say that if both the inputs are different, like if you take x value is 0 and y value is 1, okay, x is 0, y value is 1, then look at what will happen. X is 0, so you will get 0 here, y is 1, so y's complement will be 0, then you have x complement, 0's complement will be 1 and y is 1, 0 and 0 will be 0, 1 and 1 will be 1, 0 or 1 will be 1. So if both the inputs are same, you will get the output as 0. If both the inputs are different, then you will get the value 1. Okay. So 0 and 1, they are different. You will get the output as 1. 0 and 1. Okay. Both the inputs are different. You will get the output as 1. Now 1 and 1, both the inputs are same. You will get 0. 0 and 0, same. You will get 0. Same, 0, 0, 0, 0. So if you convert this binary number to the decimal number, you will get the value 3. So if you write the statement a is equal to 4, b is equal to 7, print a exclusive or b, you will get the output as 3. If you want to verify, you can verify it. Okay. Now let me discuss about bitwise NOT. The bitwise NOT is a unary operator. We'll discuss how it will perform. Bitwise NOT we will represent like this. Now if I have a value is equal to, let's take that I have a value is equal to 7. Now if I write print not A, I will get the output as minus 8. If you want to verify, you can verify it. Okay, how it came, I will discuss now. Is it clear? Now, as it is a positive number, okay, the positive number, if I want to represent in 8 bits, then how I will represent? 0, 0, 0, 0, 0, 111. This is the binary of the decimal number 7. Now, what is meant by bitwise not? How it will perform is that if the input is 1, not of 1 will be 0. If the input is 0, the output will be 1. This is the way the bitwise not operation will work. Meaning is that it is not true means what? False. Not false is what? True. So this is the way it will work. Now if you see it, now this is the input. Now I want to perform the bitwise not. So as the input is 0, you will get 1, 1, 1, 1, 1, 0, 0, 0. So this is the bitwise not of the given input. Now if you look at the MSB, the MSB is 1. Already I have discussed that if the MSB is 0, then it is a positive number because 7 is a positive number. So that's why MSB is 0. Now if after converting you got the MSB as 1, meaning is that it is a negative number. And you always know that the negative numbers will be represented in a computer or stored in a computer in the 2's complement form. So this number is in the 2's complement form. If you want the original binary number, again for this one, you need to compute the 2's complement. Okay, then you will get a binary number. That binary number you should convert into decimal number to get the output. Again, I am telling, as the MSB is 1, it is a negative number. The negative numbers are stored in a computer in 2's complement form. So, if you convert this number into decimal number, you will get the wrong answer. So, first you need to convert or compute the 2's complement of this one to get the original one. Okay? Is it clear? So, as it is a 1, we know that the result will be a negative number. Keep that one. Now, you may have a doubt. Sir, how can I compute the 2's complement? Compute the 1's complement and add 1 to it. Now, you will have a doubt. Sir, how can I compute the 1's complement? If the input is 0, the output will be 1. If the input is 1, output will be 0. Same as the NOT operation. So, let me perform the 1's complement on this one. I will get like this. Okay. Now, I need to add 1 to the LSB. Add 1. Okay. Now, if you perform this one, I hope it is visible. Otherwise, I will write here. You have 1 and 1. Okay. Now, you are performing the addition. Okay. 1 and 1 will, sum will be 0. Carry will be 1. Again 1 and 1. If you perform addition, you will get the sum as 0. Carry as 1. Again 1 and 1. Sum will be 0. Carry is 1. Now 1, 0. It will be 1 and these all are the zeros. Okay. So if you convert this number to decimal number, you will get 8. And I already told that it is a negative number. So it is minus 8. I hope it is very clear for you. Now you will have a doubt. Sir, it is a positive number. It is fine. Okay. Let's take that instead of 7, if I am taking minus 7, what will be the output? The output will be plus 6. If you want to verify, you can verify it. If you does not know how it will work, you please write in the comment section. I will discuss this one in a separate video. Even we can perform the bitwise NOT on the negative numbers, and this is the number you will get it. So how I am saying the shortcut for you is that if it is a positive number, okay, then if you want to compute the NOT operation, then it will be minus n plus 1. That is the way. Plus 7, we got the output as minus 8. If it is a negative number, you will get plus n minus 1. That is why minus 7, you got positive 6. So this is the way the bitwise NOT operation will work. Now let me discuss about the right shift and left shift. These are the shift operators in the bitwise only. Okay. Now let me discuss about the right shift. The right shift will be represented like this. Okay. Now let's take that a value is equal to 4, and if I write a statement called print a right shift 1. Now the right shift will be represented like this: a right shift operation b. The meaning is that this is the given input, which is an integer. Now b means how many bits you want to perform the right shift, whether you want to perform right shift by 1 bit, or you want to perform the right shift by 2 bits, or you want to perform the right shift by 3 bits. What is that one? That will be represented with the value called b. So here I have written the value b value as 1, meaning is that I want to perform the right shift by 1 bit. Is it clear? Are you able to understand it or not? Now you look at it. Please convert this 4 into binary number of 8 bits. Then you will have 4 zeros, 0, 1, 0, 0. Now you need to convert the right shift operation by 1 bit. Right shift what? You have to shift it. Is it clear? So let's take the 8 bits here after conversion. How many are there? 4, 8 is there. Now right shift. This 0 is there. You need to right shift it. You will get the 0 here. This 0 you will get here. Okay? Are you able to understand it or not? Sorry. Okay? This is the first bit. The first bit, if you right shift, it will go out of the boundary. The second bit, if you right shift by 1, this one you will get here. You will get 0 here. Here it will be 1. Okay. This will be 0, 0, 0, 0, 0. And here you will get the 0 because that last one is vacant. So you will keep the 0 here. So this is about the arithmetic right shift. Okay, are you able to understand? If it is an arithmetic right shift, you will keep the MSB as it is. Okay, are you able to understand? So that is the way you got it. Now if you convert this, how many zeros? 6 zeros, 1 0 to the decimal number, you will get the value as 2. So this statement will print the output as 2. Now if I want to perform again bitwise right shift by 1 bit, then you can try it how it will work. Again I want to perform right shift by 1 bit, then this 1 will go away, you will have a 1 here, this 0 will go away, you will have 1 here, then 0 0 0 0 0 0 0. So if you convert this binary number to decimal number, you will get the value as 1. Okay, so the right shift operation, how you can perform is that in a shortcut way is you have a right shift b, then you can simply perform it as a by 2 power b. Is it clear? Are you able to understand? Look at here, I have 4. I want to perform right shift by 1 bit, then 2 power 1, which is equal to 4. Which is equal to 2. Sorry for it. Okay. Are you able to understand it or not? So this is about the right shift. Now let me discuss about the left shift operation. We have left shift. Left shift will be represented like this. Now let me take it. A value is equal to 4. If I write print a left shift by 1. So again it is in the form of a left shift operator and then b, where b represents how many bits we have to perform left shift. Here the b value is 1, so we need to perform left shift by 1 bit. So I need to convert this 4 into binary number. How it will come? 0 0 0. Okay, then you have 0 1 0 0. So this is the 8-bit representation for the value 4. Now I want to perform left shift. Again, take the 8 bits. Okay. This 0, if I left shift, I will get here. Because this is the first bit, if I perform the left shift, it will become second bit. And the second bit will come in the third bit. Third bit will come in the fourth bit, like that it will come. And here you will keep the value 0, because this will be empty, you will keep the value 0. So this is the binary number you will get if you perform left shift by 1 bit. If you convert this one into decimal number, you will get the output as 8. So this is 8. Again, if you perform left shift by 1 bit on this input, you will get the output as 16. So how the left shift can be computed easily is that if you have a left shift b, then you can write it as, okay, a into 2 to the power b, which is equal to, suppose let's take that here I have 4 left shift 1, which is equal to 4 into 2 to the power 1, which is equal to 8. If I say 4 left shift 2 bits, then 4 into 2 to the power 2, which is equal to 16. So this is about the bitwise operators. Now let me show these things practically in the Jupyter notebook. Now let me take the two variables a, and I will initialize the value 7, b is equal to 4. Now let me perform the bitwise AND. Okay, a bitwise AND b. Okay, then I want to perform the bitwise OR also. How I can perform the bitwise OR? I will use a bitwise OR b. Similarly, I will use not, okay, a. Is it clear? If I perform not a, we will perform the bitwise not. Similarly, I want to perform exclusive OR between the a and b. Similarly, I want to perform logical right shift by 2 bits. If I want to perform the right shift, let me see what will happen. If I want to perform the left shift on the B with 3 bits or 2 bits, let me take it. Now let me see what will happen in this case. If it is a bitwise AND, we know that the given integer value will be converted into a binary number, and then on the each binary bit by bit, the bitwise AND operator will be performed. If it is 7, if we convert into a binary number, it will be triple 1. For 4, it will be 1, sorry, 0 1 0, sorry for it, 1 0 0. This is the binary number for value 4, and this is the 7. Now if I perform bitwise AND 1 and 1, it will be 1, 1 and 0, it will be 0, 1 and 0, it will be 0. So if you convert this one to the decimal number, we'll get the value 4. Similarly, let me verify the bitwise OR operator. Again, the A value is 7, so if I convert into binary number, I will get triple 1. B value is equal to 4, so if I convert into binary number, I will get 1 0 0. Now, I need to perform the bitwise OR operation on bit by bit. Bitwise OR 1 will be 1. 1 or 0 will be 1. 1 or 0 will be 1. So we got the binary number as triple 1. If I convert into decimal number, I will get the value 7. Is it clear? Now if it is not operation, already I have discussed, if it is a positive number, the not operation we will get minus 8. If you have a doubt, already I have discussed, you can verify it. Is it clear? Now let me discuss the exclusive OR operation. How the exclusive OR operation will perform? The A value is 7 will be converted into binary number, which will be triple 1, and B will be 1 0 0, which is 4. Now exclusive OR operation. If the two
bits are same, it will return the value 0. Look at here, 1 exclusive or 1 will be 0. 1 exclusive or 1, sorry, here it is 0. 1 exclusive or 0 will be 1. 1 exclusive or 0 will be 1. So we got the binary number as 0, 1, 1. If I convert into decimal number, I will get the value as 3. And another one is that we are performing the right shift on the value which is stored in the variable a by 2 bits. Okay. Now, right shift, if I do it, it will be what? It will be divided by 2 power 2. So 7, if I divide by 2 power 2, I will get 7 by 4, which will be 1. Roughly I will get 1. Let me verify it. And if I perform the right shift on the B on 2 bits, if I perform 1, sorry, this is left shift. Sorry for it. 4 left shift on 2 bits. If I do it, 8, it will become 16. We'll verify whether these outputs are coming correctly or not. Look at here, 4. Whenever I'm performing 7 bitwise and B, which is 4, 7 and 4, if I'm doing, I got the value as 4. Now 7 bitwise or 4, I got the value 7. Not, I'm getting minus 8. Then I am getting exclusive R, A exclusive R B, which is 3. Okay, this is exclusive R. And right shift, I got the value 1. You can verify it. And 16 is correct. So whatever we have guessed, all of them are correct. Now, if you want to verify the bitwise not for a negative number, let me take a value is equal to minus 8. If I perform bitwise not on a negative number, okay, we will get the output as plus 7. If you have a doubt, you can verify it. We'll get the plus 7. So if it is a negative number, it is very simple. Change the sign and decrease the value. You will get 7. So 8 is there, decrement the value by 1, you will get 7. Change the sign, which is a negative number, you will get plus sign. If it is a positive number, if it is an 8, if I perform the bitwise not, I will get minus 9. If you want to have a doubt, you can verify it. You will get minus 9. How? The shortcut is very simple. Add the value by 1. So we have the 8. Add 1 to it, it will become 9 and change the sign. So if it is a negative number, we will decrement by 1 and change the sign. If it is a positive number, we will increment the value by 1 and change the sign. I hope it is very clear for you.
Now let me discuss about assignment operators. Assignment operators are used to assign values to the variables. Now let me discuss about the assignment operator. If you have a statement called a is equal to 4, now you are assigning a constant value 4 to the variable a. Is it clear? Similarly, let's take that you have assignment operator like this, a plus is equal to 4. This one even we can call it as a shorthand operator also. This will be represented as a is equal to a plus 4. Okay, if a value was initially 4, then 4 plus 4, a value will be updated to 8. Okay, so we are assigning a value to the variable. Even if I have a plus is equal to b, then I can write it as a is equal to a plus b. Okay, then you may have a doubt, sir, I have a plus is equal to, instead of only one variable in the right hand side, I have an expression called a into b. Then how it will work? Then it will be a is equal to a plus a into b. So first a into b will be performed. On that result, a will be added and that value will be stored in the variable a. So this is about assignment operator. In any programming language like C and Python, Java, this equal to will be considered as an assignment operator. and double equal to will be useful for you to compare whether they are equal or not. If I write a is equal to 4, then meaning is that I am assigning the value 4 to the variable a. If I write a is equal to 4, then I am comparing the value in the variable a and 4 is equal or not. Okay. Now, let me show these things practically in the Jupyter notebook for you.
Now, let me take a variable a and let me assign the value 8 to it. If I print the a value with the help of print function, now look at here what will happen. The integer constant 8 will be stored in the variable called a, and whenever you are displaying the value which is there in the variable a, it will be printed output as 8. Now let me discuss the few more examples related to the assignment operator. Let me take the b is equal to 1, meaning is that we are storing the integer constant 1 in the variable b. Now if I perform assignment operator b plus is equal to a, okay, then if I write print b, then what will happen you can verify here. Okay, if I write like this, which is nothing but b is equal to b plus 8. So what is the b value, which is 1? What is the a value? 8. So 8 plus 1, 9. That will be assigned to the variable b. Okay, now 9 will be stored in the variable b. Whenever you are displaying the value which is there in the variable b, 9 will be displayed as an output. Now let me discuss one more example. Let me take b plus is equal to a into b, and I am displaying the value which is there in the variable b. Now what will happen, we will look at here. B plus is equal to a into b, so it will be b is equal to b plus a into b. Okay, so first a into b will be performed. What is the a value? 8. What is the b value? 9. Okay, then you need to add that one to the b value. What is the b value? 9. So it is nothing but 9 plus 8 into 9. We need to perform the multiplication first. Okay, so it will be 9 plus 72, which will be 81. That will be stored in the variable called b. Now you are trying to print the value which is there in the variable b, so 81 will be displayed as an output. Okay, now we can run this program and see whether we have guessed it correctly or not. Yes, the first a value is 8, the next b value is 9, and then next b value is 81. I hope it is very clear for you how the assignment operator will work. Even assignment operator can be called as shorthand operator. If you still have any doubts, feel free to ask me in the comment section.
Now let me discuss about membership operator. Membership operator is used to check membership in a sequence such as list, tuples and string. Now let me discuss in detail about the membership operator. We have two membership operators such as in and another one is not in. Okay. Now let's take that I have a value is equal to 10 and then I have list 1 is equal to 1, 2, 3, 4, 5. Now verify whether 10 is there in this list. List consists of elements such as 1, 2, 3, 4, 5. 10 is not there. So if I write a print statement called print a in list 1, does 10 is there in the list 1? Not there. So it will print the value called false for you because 10 is not there in the list. Similarly, if I say print a not in list 1, what is a value? 10. 10 is not there in the list. That is what? Correct. So it will print the boolean value called true. Is it clear? Are you able to understand? Let me discuss one more example for better understanding. As I said, it will be check membership in the sequence such as strings, tuples and list. We already discussed about the list. Now let me discuss about with respect to the string. Let's take that I am taking A is equal to S. Okay. So I am assigning a character S to the variable A. Then let's take that I am taking B is equal to, okay, Pernica. I am taking the string called Pernica. Now, the character S is there in the Pernica? No, because it is consists of characters called P, A, R, N, I, K, A. So, the S character is not there in the string called Pernica. If I say print A in B, B is a string and A is consists of a character. That character is there in the string or not? It is not there. So it will print false for you. Are you able to understand? Instead of yes, if I give the character P, then if I verify print A in B or not, P character is there in the B string or not? Yes, it is there. So then it will print true. Is it clear for you? So let me discuss these things practically in the Jupyter notebook for you. Now let me take a variable A and assign value 10 to it. Then I will take a one list variable called B and assign values 1, 2, 3, 4, 5. So in a list we have 5 elements. They are 1, 2, 3, 4, 5. Now I want to verify whether value 10 is there in the list B or not. Now A is consists of value 10. Whether element 10 is there in the list B? No, it is not there. So it will return false value for you. Now you can verify A not in B. Yes, value 10 is not there in the list B. So you will get the output as true. Now let me discuss one more example. Let me take a variable C and it consists of a character called S. And I will take one more variable and assign the string called Pernica to it. Now I will write print C in D. Now look at here. What is the C consists of? It consists of a character S. Whether character S is there in the string called Pernica, it is not there. Similarly, if you write print C not in D, then this one will return the false for you. Why? Because S is not there in the string Pernica and this one will return true for you. You can verify it. See, we got the false and true. So I hope you have understood the membership operators. Now let me discuss about identity operators. Identity operators are used to compare memory location of two objects. We have two identity operators such as is and is not. If I am using is, the object 1 memory location and object 2 memory location is same, then it will return the true value. Now let me discuss this one in detail for you. As I said earlier, we have two identity operators such as is and is not. Okay. Now I have the a value is equal to 4, b value is equal to 5. If I write c is equal to a, and if I write the statement called print a is c, then it will return the value true for me, which is a boolean way. Similarly, if I write print a is not b, then it will return the true. Yes, because the memory locations of the a and b are not same, so then it will return the true. Okay. Similarly, as a and b are integers, if you write print type of a is type of b, as both of them are integers, then it will return the true for you. Now let me discuss these things practically in the Jupyter notebook for you.
Now let me write a statement a is equal to 4. So we are taking a variable a and assigning integer constant for it. And let me take a variable b and assign the value 5 to it. And let me write a statement called C is equal to A. And then if I write print A is C, then it will print the value true. If I write statement print A is not B, yes, it is true, so it will return the value true for you. If I write a statement print type of A, type of A is integer, am I right or wrong? And similarly, if I write type of B, that is also an integer, because for a variable A, we are assigning an integer constant, so it will be an integer variable. Similarly, for the variable B, we are assigning an integer constant 5, so this is also an integer variable. So integer variable, we are comparing with an integer variable or not. Yes, it is true. So if you have a doubt, let me run this one and see the output here. So we got 3 truths. I hope you have understood the working process of identity operator. With this video, I hope you have understood all the operators in the Python, such as arithmetic operator, comparison operator, logical operators, bitwise operators, assignment operators, membership operators, and identity operator. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.